Without further ado, I want to introduce our next set of speakers. With us today, we have YJ Lim and Josh Chen with MathWorks. Josh is a senior software engineer at MathWorks, been focusing on generating ROS toolbox to generate production-ready C++ code. And YJ is the principal manager for robotics and automation systems at MathWorks. They've been valued partners in generating like a lot of collaboration around Simulink to generate ROS control code. We're really excited to get this update from a lot of the tools going on in the robotics toolbox, in particular around ROS2 control. Josh and YJ, the floor is yours. Thank you.
Thank you so much, Matt. My voice is on.
Can you turn it on?
Okay.
Do you mind raising it?
All right, cool. All right, so thank you again, Matt. So we have been doing this project for quite a few years ago now. I must acknowledge the highs. Probably he's somewhere in the other line of the internet. So the highs is really helping us creating the ROS control from the Simulink control model. You know, we presented this one a couple of years ago here. We now ROS2 control from the Simulink control model, which is great. So we will go there. But before that, just want to check. They're working? Not working. All right. Okay. All right. Cool. So we, Josh and I, come from MathWorks, based in Boston. There are a couple more people from MathWorks folk here as well. So as you know, we are creating MATLAB and Simulink. So MATLAB is the very high-level language in the programming environment for the data analytics, algorithm development, visualization, numeric computation. We do have another platform, the Simulink, which is a graphical programming environment, and you can do the more like a modular design approach here. So people are using this Simulink for modeling, simulation, and testing and deployment your system. So, and also the Simulink is nearly known as the de facto control development tool. We do also have more than 100 add-on toolbox for the specialized task, the robotic toolbox, and then the deep learning toolbox, ROS toolbox, obviously. We speak a lot robotic and autonomous system, a robot in the ground, a robot in the air, like a drone, robot in the underwater, and then obviously in the factory floor. So we see a lot of our the MATLAB-based the user, they are now really leveraging the ROS and ROS2 the capability more and more. Through our comprehensive support for the ROS and ROS2, we really committed to empower our researcher and engineer in the robotic community. So, I will briefly discuss about how we support ROS and ROS2 from the MATLAB Simulink, and then Josh will take over how we create ROS2 control from the Simulink control model. I need to mention about automated ROS2 controller generation from the Simulink model. I feel like this is pretty the interesting and cool the feature that we have that you can take advantage out of this the new feature, new update that we have. So as you do today, like you can program ROS using the Python or C++. You can also do the ROS programming in the MATLAB and Simulink. So I will talking about that thing here more and more. All right, so we do have the MATLAB API. Then you can program ROS node in it. You can utilize publisher, subscriber, service, and action, and then you can also using the MATLAB toolboxes, using our specialized tool like a computer vision toolbox and a machine learning tool and a deep learning toolbox for your the daily job. It will make a lot of easy for that kind of workflow. We also do more and more people using ROS in a software engineer in the background, like a mechanical engineer. They see the value of ROS, so they have a pretty long learning curve using the native ROS. So we make that easy, right? You don't need to have some expertise, CMake and C++ knowledge. So we make that easy a lot. After you design or creating the ROS programming in the MATLAB, and then you can automatically generating ROS the ROS code, the C++ ROS code. Also, the CUDA compatible ROS code as well automatically. So that's pretty easy. We make just one click, and then you can generate everything right away to be the ROS code. Similarly, from the Simulink side, you see here a bunch of ROS block, and this is all we created. You can the drag and drop, and you can have publish and subscribe that's out of it. Again, Simulink is really model-based design in a tool. You can modeling, and then you can simulate it for the model-based design approach. Same thing, pretty make easy, right? Everything you can do within the Simulink the environment. Same way, and you can create after your design is done in the Simulink environment, and then you can generate it in a ROS C++ code out of it. Our team, I think, did a pretty the great job. And you see here, we have a major ROS functionality from both the MATLAB Simulink, ROS, and also for the ROS and ROS2. More and more people, they now using the ROS2 more and more. So, but still like an enterprise account, they still have some lag, but mostly today they already migrate to the ROS2. In addition, we have a whole lot of new the ease of use tools. So I will introduce one of them example in the later slide. So it's really, the job is really making the ROS programming easier using MATLAB Simulink and for the ROS and ROS2 programming. So I want to talk about how today the MATLAB and Simulink-based customer, how they use ROS in this slide. So in the left-hand side, this is a very high level how MATLAB Simulink being in use, right? You can do the algorithm development, perception, planning, and control is within the MATLAB Simulink for the robot manipulator or ground robot and UAV or even other heavy-duty machinery or maritime robot as well. And also you can do the data analytics as well, obviously. More and more people, they are interested to use our tool for the production workflow with the BMB tool we have. So one example here, and then right-hand side, typically you have a ROS network. You can have a ROS-based simulator. We heard like from the picnic, there are various robots. They do provide the ROS driver. So by connecting to the ROS network, from the MATLAB Simulink, you can do, for example, co-simulate with Unity or co-simulate with iJunction. That's really typically they connect to the external ROS network from the MATLAB Simulink. They start to developing their system. After they done the system development, as I said like earlier, from the MATLAB and Simulink, you can automatically generate ROS and ROS2 code out of it. We do a lot the ROS spec data. So you see the arrow is here coming from the net. So we used to bring only the ROS spec, the data, and to visualize and play back. So we do now have our customer base, MATLAB customer and the Simulink customer. Hey, can we create the ROS spec data while they simulating in a Simulink, for example? So I'm going to talk about there a little bit here. This is a new feature that we just released in the 24A 1 week ago. You can visualize and analyze ROS-I and ROS-II back. And you can really bring multiple topic in the one the panel, and then you can simultaneously visualize every data. Not only ROS back data, you can also visualize the live ROS data as well while you are simulating within MATLAB Simulink. You can also read and visualize the ROS back data that's stored in the AWS as well. So we want to talk about more this one in the afternoon in a demo section. If you are interested, please come over our table, and we can discuss some more about this one. Using ROS, you can really connect and control robot hardware. This is one example from the MATLAB Simulink. In the window machine, you can connect to the UR machine. Again, in a 24A, we now support ROS-II, and using the universal robot ROS-II driver, you can really develop your algorithm. This is one example, a pick and place example that Joe talking about in Picnic. So there are a lot of things we can talk about. Hey, how I can do the object detector for machine learning and deep learning, how I can do the shift-stop in a pose estimation. We do have quite a bit of motion planner that Joe was talking about using the movie. We have optimization based in the chunks, the manipulator motion planner. So, and also in a 24A, we do have deep learning based chunks as well to speed up your motion planner. So same thing. We're going to talk about this one in our demo booth in the afternoon. So come over our table. Let's have a more conversation on this. This is a very simple example. We are creating more in a challenging problem in a material handling for the cobot. So that's it. So this is pretty high level how we support ROS-I and ROS-II out of MATLAB Simulink. So Josh is going to talk about how you can create ROS-II controller out of Simulink.
Thank you, YJ. All right. Hey everyone, I'm Josh, and today I would like to focus on showing you our new feature from Simulink to ROS-II control. A couple years ago, Hayesh and my colleague Murat present a ROS control plugin, which allows you to generate a ROS control plugin directly from Simulink model. Since then, we received many customers asking this same feature in ROS-II. And here it comes. Architecture-wise, it's pretty similar as ROS-I. It's a layered structure, layered architecture. We grab the handles from hardware, although slightly different, we are using the ROS-II syntax for this one. And also, as you may already know, ROS-II control is inheriting from lifecycle nodes. We will get more about that later. With this feature, we provide the Simulink model as your controller. Now, let's quickly jump into a case study. For Simulink, it is a model-based technique to design during the simulation process. And now what you see here, the perception, the plan control, and the plans, everything is a Simulink model. From the perception, we receive the point cloud by scanning a curved object and then generate a point cloud for us to follow the path. For planning, this is not exactly a controller, but we are showing the concept that after getting something, we plan our path, or you can develop your own controller algorithm, and then you can directly send those joint commands to the plans. The plans you are seeing here on the right, that is a Unreal Engine simulator provided by Simulink 3D simulation. And here you can see the picture we see from the perception. Putting everything together, you will see these robots moving based on our trajectory planned. Now, after we plan our controller, we want to get rid of the perception and plans because this is the part we need to deploy to our actual device. When I talk about device, it can be either a simulator from Gazebo or other simulation platforms, or it can be an actual robot. Now, before doing that, you might notice that from the left side, we are cutting out the perception and cutting out the plans, meaning that there's input and output ports now hanging around without connecting to anything. So we need to fix that problem first. Now, the yellow part on the right side is exactly the same as the one on the left side. First, we need to connect those to the position interfaces. These output ports maps with the handles of your controller's command interfaces. And same as that, for input side, these input ports maps to your handles to your state interfaces. And of course, you can also add any publisher and subscribers into your model. And when you generate code, it follows the real-time pattern. Now, as many of you already know, ROS-I controller is inheriting from the life cycle, which means it allows us to transition from one state to another. Now, whatever you design in your Simulink model, that maps to the active state, meaning that for each time step, when you call it, it executes the entire model. And then through those get position interface and set position interface, it interact with the actual hardware. We already handle all the creation, activation, and deactivation under the hood, so you don't need to worry about that. But what if you actually need some customized code? You can use the initialize subsystem block, which would be triggered in activating stage, the reset block, which would be triggered in error handling and the deactivating state, and also the terminate, which would be triggered in the shutdown state. These would also generate code automatically from the Simulink code generation architecture. Now it's time to put Simulink model as a controller. So I would like to go through this video real quick. In this video, you will see how we interact from Simulink to first configure the interfaces, and second, select which Linux machine you want to deploy to, and finally, how you can click a single button to deploy everything to your Linux machine. So let's play the video. This model is exactly the same as I showed earlier. And first step, configure ROS control setting. Here's the app, and you can see the input ports is mapping exactly as what you provide in the model. You can set the resources type as what provided in the ROS-I control framework. Same thing applies to the output ports. And you can also specify the parameters which you would like to generate as a ROS-I parameter. After clicking OK, we now need to specify your device that you want to deploy to, IP, username, password, and also the workspace. With that, you just need to click the build button, and that would generate the code directly to your Linux machine as a ROS-I plugin, ROS-I control plugin. Now, once you see success, you should be able to see the same text in your remote device as well. Now, until this point, we are also interacting with Simulink or MATLAB. Everything after this point, that's absolutely on your own, meaning that it's either your remote machine or your robots. So let's go to another slide. First of all, remember we specify where you want to deploy it first, right? So here is where you will see the generated package located. And after deploying, there's only one more step you need to do. We already prepared this precompiled syntax for you. So you just need to copy paste your controller to your YAML file so that the controller manager are aware that, hey, there is a new controller we can use. And right after that, you can just launch your existing project. Here I'm showing when published side by side and publishing a message of a list of waypoints for the robot to move. And of course, the reason it's holding here is because by default, I'm setting the hold value to true. Now I'm holding that, so it's start moving. And one thing I want to highlight is this is the exactly same model we are doing in the simulation. So which means you can use the model-based design to simulate until you are satisfied with your controller. Then you deploy everything to your actual device. Now, in summary, we can develop the entire system in Simulink with a model-based design, and you don't need to actually write any code. With one click button, you can deploy the entire thing to your actual robots or remote devices. Now, we also provide an app allow you to do customization for your names or parameters you want to generate as a ROS-2 parameter in the ROS-2 control app. And these bring us to the end of our topic today. In summary, we talk about how we can use Simulink and MATLAB to do model-based design for ROS control and ROS-2 control framework. And it is an easier way for you to generate code and reduce the possibility of handwritten issues when you are writing code. And it's an easier way for you to develop an implementation workflow. I would like to encourage you to download a trial and try it out yourself. And feel free to reach out to us to work on the real-world industrial applications you have. We, of course, have more products, as YJ mentioned. Make sure you check out our website and our GitHub page for our robotics-related applications as well. And that's all. Any questions for us?
Hey, guys, I appreciate you guys taking the time. Any question? We have time for at least a question. Yeah, Omar.
So, verify, and gain access to full ROS capabilities by using.
Can I answer? Yep, that's exactly true. So yeah, you can design everything from the MATLAB Simulink, and then even in a MATLAB Simulink environment alone, you do have the major capability of ROS and ROS-2.
Is it all fully enclosed within a MATLAB environment?
Yep. Yep. Yeah, we do have all the function and the block, so you can use it right away.
Yes,
we can talk more about it.
Just in addition to that, for the ROS-2 control is releasing in 24B, so you might not be able to try that now, but for the rest, you should be able to try.
You have an online question there.
Oh, thank you. So the question, are there any limitations to the type of robots that can be used with the generated ROS-2 controller plugins? From Heish.
Oh, it's from Heish. Great. Yes, so right now we support the acceleration, velocity, position, and effort. I do know that for the general ROS-2 control, we also provide a customized option. That one is going to come in the future, but not for 3Ds.
Perfect, thank you.